All right. Today we are going to be covering technical session number 2, Introduction to Computers. We're going to be getting our basic overview of computers, what they do, what constitutes a computer, possibly get into a couple different types of them. Look at
Hello.
our, hello?
Yeah, I'm not able to open the PR.
Okay. So our objectives for this particular technical session is going to be able to describe how computers work, including the relationship between hardware, software, and firmware. Also explain the key safety precautions to take and tools to use to protect yourself and the computer when working on them, and some basic safety tips along the way. The behavior, skill, and mindsets we want to keep in mind while working on this particular technical session is growth mindset, of course. We always want to be actively learning, developing, growing, open to new information, or sometimes even older information, and apply it to what we have. And then we also want to remain adaptable, to be able to change as the information comes in, not be steadfast in a singular perspective with regards to the technology, but understanding that it's constantly changing. We have to change with it. So first, we're going to start off with basically, what is a computer? What constitutes a computer? Well, it is, in very basic terms, defined as an electronic device for storing and processing data according to instructions given to it in a variable program. So the phones we keep in our pocket, calculators we may use at school, cash registers at this point, tablets, and then what we would traditionally associate with computers, the desktop and the laptop itself. Smartwatches, we're seeing computers everywhere. Oddly enough, ovens, washing machines, dishwashers, those are basically becoming computers too. So pretty much for the parameters of this course, we will be focusing on 4 main types of computers when you're dealing with the largest type you can find, which are the supercomputers. They're fastest, they're too big for personal use, typically used for very, very large computations. Big Blue is probably one you may have heard of, that IBM runs, requires a facility to house it, it's mainly used in science and academic communities, as well as another example would be car manufacturing. So very, very large computers, very expensive, very powerful. Then we get down slightly below that, you have the mainframe. Tons of storage, lots of input-output devices, can handle a vast multitude of connections, and can connect across vast distances. Example of this would be a server. Then we start getting into things that you and I might actually work with for the most part on our day-to-day operations, the mini and the microcomputer. So the mini, which is faster than a micro, holds more storage, has access to more input and output devices. You might see this on point of sales machines, all connecting to one essential computer. So the essential computer that is connected to all the point of sale machines, like you would have it, Walmart, Target, grocery stores, what have you, Myers, would be connected to a mini computer that would communicate with all of them. The point of sales would actually be considered something called a thin client, which is a stripped down version of a computer meant for a singular purpose. But we will get into that when we get into custom configurations. And then finally, you get to the microcomputer. It's called a micro because the chip is small and affordable, not because of its actual physical size. And we typically would see this in our daily lives. This is our typical desktop computer that we would normally use. This is considered a microcomputer. All right. In the most basic sense, you can break down the components, computer parts into three main categories. You have your hardware, your software, and then the firmware. Easiest way to remember it, hardware is pretty much everything you can touch. Software is what you would put onto the computer, like Windows or Mac OS, any applications. This would be the code that is actually running on the hardware itself. So that would be software. And your physical components would be like your webcams, your monitors, the actual desktop part itself, the microchips, the RAM blades, PCI cards, all the stuff that you would physically touch and put into the computer, that is under hardware itself. And then we get to firmware, which is a specific hardware chip that has software stored on it. The two biggest examples of this are the BIOS chip and the ROM chip. And we will get more into those as we go along. Questions so far? So hardware is everything you can touch. Software is the code or programs you put on the computer, and firmware is either the BIOS chip or the ROM storage, which is a hardware chip with software stored on it. Yes, Candido.
These lectures are also on Canvas when we go through them, or no?
Do what?
Are these lectures available on Canvas as well?
I'm going to be uploading them to YouTube, but also the
I'm talking about the material.
oh, the presentation.
Yeah.
Every day, once we are done with the lecture, the presentation that we go over, we will put a student paced version of it in Slack in the class channel, so you will have access to the slides.
All right, thank you.
So you can review, you can go over them again.
All right.
Mm-hmm.
Thank you.
All right. All right, hardware. So we talked about a little bit earlier, it's all the physical components, connectors, slots, ports, physical ports, because there are software ports. So physical ports and peripherals. So, like we said, anything you can touch. So you have a variety of them up here shown you can look at, and it's pretty straightforward with regards to hardware. Firmware, software stored upon the hardware. So we talked about that being the ROM and BIOS chip. This is the startup instructions for low-level hardware. So when you first turn on the computer doesn't know where to go looking for things. So it's keyed into the BIOS. And the BIOS says, okay, you need to go to this spot to look for the operating system so that you can get further instructions to know how to turn on. Here are the other things that are connected to you, and here's how you talk to them. So these are basic instructions that are in there and built into these chips to essentially key the system up to let it know where to go looking for things, how to interact with things, and in some points, date and time and various other functions are stored in here as well. So typically this chip is on the motherboard. It is already soldered to the motherboard, so it is physically attached. It's not something that you can just swap out. It does not change readily. You do need a special utility to kind of upgrade software on it. And I will tell you, NIT flashing, it's called, when you're updating the operating system on the BIOS, it's called flashing the BIOS. And it's one of the more stressful things you can do, because if you interrupt this process at all, you are the proud owner of a very expensive paperweight. So if there's any interruption, if there's a power flash, anything like that, that device is now a brick. So you need to take special precautions when you are updating the BIOS or flashing the BIOS to make sure to mitigate as much of this risk as possible. So you'll hook it up to a UPS. Some people will even go as far as to hook it up to 2 UPSs off of separate breakers, just to make sure that you know, there's no possible chance that it can go, you know, it can go bad. But we will get into that a little bit more when we start talking about BIOS. So these are data and instructions stored on ROM chips or read-only memory. Well, that is a little bit of a misnomer now because we can now update them. All right. Questions so far with regards to firmware? All right. Software broken up into two very basic groups. You have your operating systems versus your applications and programs. So your operating systems, you know, the big ones, you know, your Windows and your Mac OS. And we just talked about a little bit earlier, Linux. If you're not familiar with that, you will become significantly more familiar with it over the next 3 months and get some hands-on practice with them as well. And so the operating system essentially is a user interface to control all the hardware that is attached, your microphones, your monitors, your keyboards, your mouses, everything. And it manages this communication with software and drivers, essentially. Runs applications, so applications run on top of the software itself. So you're like Microsoft Word or Excel, what have you, all that runs on top of your particular operating system. It controls your inputs and outputs, and we just went over some of the examples here in a minute, you know, a few minutes ago. Now, applications and programs, these are very specific. They perform useful human tasks. They run on top of an operating system. They are written for specific operating systems. So if you have, say, Microsoft Word, you can run Microsoft Word on Mac OS. It's a different version. It's coded differently to be able to interact with that operating system, which is why when you go look for downloads, they'll have different types of downloads for whatever operating system you're working off of. Examples of this, Apple iWork, independent computer games. So if you're on a Mac, you're pretty much not going to see many computer games, although that is starting to change, and Microsoft Office as well. So operating systems are your core containers that you would use to interact with all your hardware, and then you run software and applications on top of it to make it more useful to you as an individual. Questions so far? All right. All good things to know right here. Everything that is run on a computer is either a 1 or a 0, also known as binary. And you can think of it kind of like a light switch. It can either be on or off, a 1 or a 0. So that's how binary itself works. So when we type in letters into the computer does not see those letters. It sees the 1s and 0s associated to make those particular numbers. And it is operating off of what's called base 2 math, because it can either go on or off, right? So it'd be 2 times 2 times 2 times 2 times 2 times 2 as you for each bit that you add. And a bit is a single 1 or 0 right here. So a single 1 or 0 is a bit. You clump 8 of those together and you get a byte. We will do a lot of work with bytes, especially when we start talking about IP addresses. So you have 8 1s or 0s that operate together, create a single byte. Also, if you have 4 of them together, 4 1s or 0s clustered together, you get what's called a nibble. This becomes important when we're talking about hexadecimals. So yes, you are going to get to learn about hexadecimals, how to calculate them in here, where they come from. And they're used for things like IP version 6 addresses. If you see like numbers and letters strung together in your IP address, that is a version 6. If it's just numbers, it's typically a version 4. But it's also important when you're looking at MAC addresses, which we will also get into that a little bit later. You will learn how to calculate it. It's not as hard as it's made out to be. It's actually pretty straightforward. We do have a little program called ANDing which will help with you learning how to do IP addresses and correlating that with, binary, as well as hexadecimals. And we have a game, a nice fun game. If any of you are looking to start up a Twitch game, we have a game called Flippy Bit. So, which will help you learn how to do binary to hexadecimal pretty quickly. And it's kind of like, what would you say, Mark? Was it kind of like Galaga or Missile Command or something like that? One of the really old Atari games. So it's kind of like that, but your input is based off of binary to create the hexadecimals to be able to shoot your missiles. So it's, it's a fun little game. I think Diego has an outstanding bet. If somebody can beat him, he'll get him a gift card. But I'm not going to lie to you, Diego's really good. So he is really good. Yep. Now, by using these bytes, we use this to be able to translate into characters that we can read. There is a standard called the American Standard Code for Information Interchange. That is, the specific binary equates to specific characters so that they can be seen. This is being replaced. So this was the old version. It allowed for up to 128 different characters. So this is the old version of it that is currently in process of being replaced. So just kind of understand that as we are going into it. This is a chart for anybody who's ever, been in IT for any length of time. You may be familiar with this. Here is the decimal or hex equivalent to the characters, how they are created. For those of you looking at this right now and stressing out, no, you do not need to memorize this. You just need to have an understanding as when they mention ASCII, what exactly that means. That is your binary to character translation. And this is the older version of it. For the test, they only mention the older version, which is this, the USC or ASCII. The newer version that's coming out is UTF-8. Which is the change of the standard. And I think that allows for like 1,111,000 different characters. So significantly more options available now versus the 128 you could do with the ASCII. Questions so far? All right. Now,
Kelly,
yes,
before we
sir.
move on real quick, I think, Mark, did you have a question? You weren't understanding something?
No, it was more of a comment. When I saw that chart, I tried to look at it and say, just figure it out. Like, okay, what does all this mean? Decimal, hex, character. So I just commented like, I don't have no understanding what it is I'm looking at, but I don't think I should. So that's why I didn't raise my hand. I figured we're
building into it.
Yeah.
We're building into it. So, basic binary, as we stated, was zeros and ones, and typically they would go in groups of 8s to create, so they'll give you a byte, which is 8 bits put together. And with those, you could do any number between 0 and 255. So with those 8 little hashes, you could create a number between 0 and 255. Then they started doing hexadecimals, which adds letters into the mix, but you use nibbles, which is 4 bits. Create a nibble. They started using that system, which is what this hex means. It's hexadecimal, and that goes from 0 to F. So as you can see, you go 0 to F, and then they go 10, 11, 12, all the way up to, they go to 19, and then it goes 1A, 1B, 1C, 1D. And as we see here, we know it can go to F. So if you see anything above F, that is not a valid hexadecimal number. We will get into this later. We'll show you how to calculate it. This is just kind of like a preview of what's coming down the pipe.
Well, I'll say what confused me about it. So I'm looking at it and I'm like, okay, I see decimal 32. I'll start right at the top where you have null, that very first line. And then to the right of null, I see 32 decimal 20 hex character space. So to me, I'm thinking if I type in 32, the hex of that is 20 and the character is space. But I can't type in 32 because you just said in the previous slide is all ones and zeros. So how do I get to 32 to translate to hex/space? So when I looked at it, my mind just exploded and I was like, we'll get to it.
Yeah. So, I mean, don't look at this as hex 20. That is actually hex 20. So that's 2 sets of 4 characters to create that. So that's how they're creating it, because the hexadecimal is it's 4 bits to create 1 hexadecimal character. So that is hex 2, hex 0.
So it's 4 characters to get to 2. What do you have? 0, 1, 1, 0? I don't know.
Something, yeah, something along those lines. Yes. So yeah.
So they get 0 to be 0, 0, 0, 0, and then that's going to be 0.
And then 1 would be like 0, 0, 0, 1.
So it's just math.
And then 2 would be 0, 0, 1, 0.
Binary.
Got it. But now I got that. Oh, okay. So it's not 20. So you look at, so even if it said 2000,
that would be 2, 0, 0, 0. So
yes,
each character in the hex is 4 bits making that character. So you have to look at them independently. And that's why you need to know exactly what it is you're working with before you can calculate it in binary, because we would calculate 20 differently than we would calculate 20.
Got it.
In like, say, an octet or a byte. So we have to know what parameters we're working with so we know exactly how it's calculated so that we know the meaning of it.
Well, since we're on it, so that's hex. And hex sounds pretty simple, actually, once you understand it. What about decimal?
Are you talking about decimal? That's just adding it up for you. The decimal is just like, this is, character 0, this is 1, 2, 3, and it's just going up all the way to 127.
But it wouldn't be 4 different binaries for decimal. That's only hex.
The way they have this lined up, this is probably an octet. It's a byte. So it's 8 ones or zeros to create these numbers.
Oh, yeah. All right. Sounds good.
Right. Leela?
Yes, you stated that a new, I'm not sure if you said table is coming out. Is that correct?
Yeah, well, there is a new table. It's not going to be on the A+. This is just something like, this is where one of those moments where it deviates the A+ exam versus reality, versus what's going on right now, because there's a little bit of a time delay. And that is the UTF-8, Union Telegram Foxtrot 8. And that allows for, it's something like 1,111,000 and change different individual characters that you can use with that new system. And no, you don't have to memorize it.
Okay. Well, we need to know it in the future, though.
No, because one of your best coworkers is Google.
Yeah.
Okay, thank you.
The thing you may need to know is how to calculate hexadecimals, how to calculate binary, and mostly using that for subnetting and stuff like that. But we will talk about that as we go, and that'll make a lot more sense as we're moving along.
All right, got you. Thank you.
So, all right. Any other questions? All right, so basic computer processes. How does it work? Data comes in, it could be you typing on the keyboard, could be you uploading a program, could be you putting in a thumb drive. Comes in through an input device, could be the camera. It's sent to the CPU by, via the memory. The CPU takes it, performs calculations on it, processes that data, and based on the input and the program installed in the memory, it will work through those calculations. Then when the CPU is finished with the data, it is presented through an output device, could be speakers, could be your monitor. If you are visually impaired, they do have Braille keyboards where they actually have outputs across the top of the keyboard. Pretty cool stuff. So depending on the output device that you have it tied to go to, you can make that, the CPU will send it off to that device. The information also can be stored in the computer's memory. Now, as we go through, our language has to get significantly more specific. So as we are talking throughout this course, you need to make very strong distinctions between memory and storage. Those are two very different things. So we have to become more precise with our language when we're talking about it. Memory does not mean how much hard drive space you have. That's storage. So memory is going to be referring to your RAM, typically. How much active memory can be used to aid in the processing of calculations. So typically when somebody is saying memory, they're referring to RAM. When they are saying storage, they're referring to hard drives or flash drives or what have you. So just want to make that quick distinction. All right, quick little quiz. Go ahead, pause for just. All right, inputs and outputs. Pretty straightforward. So you have your inputs, your keyboard, mouse, drives, scanners, digital cameras, modems, microphones. NIC, what's a NIC?
It's a network card.
There you go.
Network interface cards.
There you go. Network
Very good.
interface card. Colloquially referred to as a modem, but this is a misnomer. It is a network interface card. Modem is a very specific thing. All right. Any other input devices we can think of that are not here?
Flash drive?
Flash drives, yeah, those could be input devices.
Touchscreen.
Touchscreen can be an input.
Speakers.
Speakers, would that be input?
No, it's output.
Output.
Input and output?
Speakers themselves, if you isolate the speakers, it would be speakers themselves are the output. What would be the input portion of that?
Keyboards.
Microphone.
The microphone. See, the microphone would be the input part. Go ahead.
I was gonna say was missing is something that everyone's using right now.
Yeah.
The camera.
I mean, I get exactly where Cynthia's going because there are devices that are considered input, output. They are both at the same time. And so when you start talking about like your fancy like gaming headsets, that's an input and output device. It has a microphone and, you know, the earpiece speakers that you hear from. So technically, yes, but when you're just specifically stating speakers, that is typically output only. That's the way they're going to classify it. Mm-hmm. So, and if you go back to touchscreens is an input and an output at the same time. For the purposes of the exam, unless specifically stated as a touchscreen, assume it's just a plain monitor. I know more and more we're moving towards touchscreens in general, but unless it is specifically stated to be touchscreen, assume it is just a plain monitor.
I got a question.
Go ahead.
So printer wouldn't be considered as an input either?
Well, not specifically a printer.
Scanner.
Scanner. So a scanner would be an input. Now, if you have an all-in-one printer that does copy, scan, and print, that whole device itself would be considered an input/output. But again, if they say printer, do not assume that is an all-in-one printer unless they specifically state it. On the exam is big on this. Do not look for the exception that disproves the rule.
you explain that a little more? I'm sorry, I apologize as far as
About the exception that disproves the rule.
Yes.
You know, say like 99 out of 100 times X will be true. But you rack your brain and you're like, you know what? I know of a single example where that is not correct. And so you pick false based off of that one innocuous example. So if I say monitors are input output devices and they say that's wrong, but I'm assuming that they're talking about touchscreens.
But
So-
they didn't say it.
5 years ago, touchscreens weren't the most common type of screen, and still they are not the most common type of screen, but they are increasing in popularity. So, but you're looking for that exception that's disproving the general rule that monitors are not input devices. There will be several examples of this throughout the cohort. Like I had a disagreement with the student where they were talking about speeds of RAM modules, and he was trying to, and it said which was faster, version, generation 4 versus generation 3. And his example was if you take the absolute slowest generation 4 versus the absolute fastest generation 3 was faster in that specific example. And I'm like, but as a general rule, it's not. So he was looking specifically for that exception that would disprove the question. And that's where you can kind of get in trouble.
And you said the exception disproves the rule. That's what you said, right?
Yeah. Do not
Okay.
look for the exception that disproves the rule. You're looking for the general rule.
Mhm.
All right. So the processing aspect of the computer itself. This is done by your CPU, your RAM, your drives, and your motherboard. Predominantly, the heavy lifting is done by the CPU itself. Questions so far? This is mostly just a definitional approach, just kind of let you know, kind of working on the vocabulary a little bit, introducing you to it. All right. Outputs. Anything you can receive information from or send information out. So your network interface card, so that is, an input and an output. Drives, your modem, speakers, printer. As long as we're not talking about all-in-one devices, we're talking about specifically just speakers. The monitor itself. Any other output devices we could think of?
Headphones?
Headphones, yeah.
I don't know if that's like virtual goggles. I've yet to.
Yeah, I mean, but that would be a variation of a monitor. So, virtual reality or augmented reality, that would be an output device. So that would be something where you would be receiving input. You would be receiving that information. So, excellent example, actually. And where I got in trouble in the class, with the combination of input and output, I said specifically keyboards could be output devices because I was talking about, I had a friend who was visually impaired and they had a keyboard with a Braille readout. And that was considered a output device because that is how they receive the information from the computer itself. Again, I was looking for the exception that disproved the rule. That is a very, very highly specialized piece of equipment that they are not likely to mention. So if I took that approach on the exam, I would have gotten those answers wrong.
About Bluetooth.
Bluetooth? Bluetooth could be output, but I mean, Bluetooth is more of a communication method, not necessarily a specific item.
Right.
So
Really, you can't have like a USB Bluetooth adapter. That's hardware. Drop it in there.
that is a Bluetooth
That's-
adapter. That isn't just Bluetooth. Bluetooth is the communication method itself, where you're having an adapter that is allowing to translate that communication. The adapter is the device.
What about the mouse?
Mouse.
Yeah.
I guess there are 3D-dimensional mice that actually have haptic feedback. So if you, sorry, I have a co-pilot today. Nope. if there are specialized mice that would have like a haptic feedback, and that could be considered an output. But again, that would be a very, very highly specialized piece of equipment.
Keyboard that want input or output?
Keyboard would typically be an input. That would be you putting information into the machine. It would receive information from the keyboard.
So that means to be that want the mouse, also that want to be same thing that want to input.
Yeah, so a mouse would also be an input device.
Yeah.
So this is all from the perspective of the computer itself. Anything it receives information from, input. Anything it gives information out, output. So
what we put into the computer is an input, and what comes out of the computer is an output.
correct.
Cool.
Jessica.
You kind of answered my question, but just to confirm, I'm grasping, what we're being given right now. Those fans that we use for like our laptops to keep it cool so it doesn't overheat.
Mm-hmm.
I was trying to confirm if that would be an input or an output. So, and I'm still kind of stuck because an input you said puts info into the machine. So I kind of feel like it may be an input because we're telling the machine to turn the fan on.
Yes,
so
but technically that would be an output device because the machine is sending information to the fan to cause it to work.
Mhm.
The temperature sensors that would tell the computer that it's getting too hot and needs those fans on, that would be the input mechanism for the computer.
Gotcha. Okay. Almost. All right. Thank you.
Mm-hmm. You're on the right track.
All right.
Let's go with Cynthia, and then I will get with Solomon.
So let me get this straight. The input are just devices that will just send information to the computer versus output that receives info and sends out info. So output is literally a two-way communication and input is just a one-way communication.
No, output is one way, input is one way. So input would be me typing on my keyboard into a word processor. The output would be me seeing those letters on my monitor being typed on the page.
Right, that's what I'm saying. Like input devices or anything that has to do how computers work is that input is just one directional while outputs is bi-directional.
No, if you had input and output together, that's bi-directional. Output is specifically one direction out from the computer.
Got it, so it's backwards. Got it.
Yeah. There are devices that are I/O, they're input and output. So the computer will receive information from it and give information back out to it. VR goggles would be a example of input and output. It's giving you information on your monitors, but as you are moving your head, it's sending input to the computer to let it know your position and where you're looking and making those computations. So that would be both. Another one would be like a gaming controller that has haptic feedback. When your character falls or gets hit, it sends a vibration to it to let you know you're getting hit or you're falling. But it's getting the input from the controls that you're pressing to send the information to the computer. So that in and of itself could be input and output as well.
So, my question, or touch screen laptop, there were any phones that want to, that would be input or output?
For what type of screen?
Touch screen.
Touchscreen is both. It's input and output. So they would call it input output device. So you have some that are just input, some that are just output, and some that are both. So a touchscreen would be both. You're receiving information on it that based on it, showing you. Also, you're putting in information by touching the screen itself.
Okay. Solomon.
Modem, I think it's an input, not output. Modem.
Modem is both. Modulator, demodulator. It is both. So when you're connected to the internet, it is receiving information from the internet, which would be an input, and it would send information out to the internet. So out.
Okay.
A modem is both. That's how we're able to communicate two directions on the internet.
Yeah.
Yes, Mark.
Just to clarify for, I guess, when we take the actual test, if something is an input and output, and they were to ask me true or false, this is an output device. If it does both, I would say false or I would say true.
Hmm. I don't
What
think it's
they may
likely to
not
get that.
specifically ask you, is this an input or an output? What they may say
Yeah.
is here's three categories. Sort these devices into input, input and output, and output.
Right. They wouldn't try to trip you up like that. If there was something that they were showing that it has two options, if it's input and output, they wouldn't do that. They wouldn't do that on the test. You wouldn't see that.
So
Okay, so let me give an example. I know you already answered, but I just want to be clear. So let's go back to a touch screen. So it's a true or false. A touch screen is an output device. That's true.
yes,
They wouldn't say false. It's an input output device, not output.
not typically, no.
Oh,
Not a lot of trap questions, like that. They really don't do that with this test, with the A+.
got it.
All right. So we'll drop this in the chat. There's a document for this just for you to kind of practice, write it out on your notes, or you could take a screenshot of it and kind of save it for your records to write it out. So what would be some inputs we could use? Just to, call out to the gallery. So what are some inputs we could have since we're talking about it?
Keyboard,
Keyboard, that's a big one. So keyboard,
mouse,
mouse, Jerusalem,
Sending word or a job to printer?
would that be an input?
Yeah,
From the perspective of the printer, maybe,
right.
but we're talking about from the perspective of the computer.
Oh.
Like-
Because
Camera?
typing,
Typing, yeah, maybe a scanner.
yes.
Microphone.
Microphone, perfect. We're using one all day. Candido,
Let's see, ROM.
CD-ROM, yeah, that would be an input.
Hmm.
So we could receive our information from there. Processing, what would we use for processing?
RAM.
RAM. CPU, Miaza, very good.
All right. Good
Julian?
job.
Hard drive.
Hard drive?
Yeah.
You got one, Julian?
Drive.
Drives, there you go. Mark?
Your webcam.
For processing?
Processing, yeah.
Oh, I thought we were talking about an input device for processing. Okay.
Yes.
Did we already say the CPU? We got the CPU.
No, we haven't. That's the big one.
Okay, CPU then.
CPU, what's another good one? There we go. I'm sorry, what'd you say, Ursula?
What about saving a data?
Well, saving data, that'd be on a hard drive.
Is that processing?
Not
Not really.
really. That'd be kind of an output. Jacarita's got it, Miss Sanford, in chat.
Right, motherboard.
Motherboard is the backbone of the computer.
Job.
All right, very good. What about outputs? We can rattle off some pretty straightforward ones.
Printing, my favorite.
Screen. Printer.
Printers, there you go.
Projector.
Projector, that's a good one. monitor. If we had a CD read
CD.
write, that'll work.
Fax, if we're doing fax nowadays.
Fax,
Speakers, yeah.
they do still exist to a small degree. Printers,
GPS.
GPS.
Modem.
That wouldn't be a, I don't know if that'd be an output. Modem, yes, absolutely.
Right,
Printers.
yes. Right.
So,
I've got
drives,
projector.
Projector, yep,
Projector.
that's another good one. So
Good
all good
job.
examples.
Yes.
All good examples. Here we can kind of lay it out. You got drive, RAM, CPU, motherboard for your processing, your inputs, keyboard, mouse, microphone, various others, outputs, monitor, speaker, printers. Nick, very good, Cynthia. That's a good one. That is both input and output. Oh, we did talk about this briefly. Kilobytes in a megabyte.
Oh, boy, yes.
And pause. So some people are sitting there kind of dancing around in their chair a little bit, you know, got to get up, walk around, got to get, you know, blood flowing a little bit. We'll go ahead, we'll take, say 8 minutes, just because we want to come back at 10:50. So we'll come back at 10:50 Eastern Standard Time. So get a drink, relax for a minute. Glean, can you please go ahead and pull up test out? Unless you want to go run, get a drink real quick and come back and then we'll do it.
I'm good. That's why I did all that. Okay, so I'm sticking around.
Okay. Stop sharing here. Did I pause? So in continuing to talk about electricity, we always want to be able to protect ourselves and the equipment we are working on from shock. So like we were talking about previously, you always make sure you power down, you disconnect the power source before you ever reach inside a computer. Power, it goes through the path of least resistance, so try not to ground yourself out. Also, power supplies, printers, and CRT monitors contain components that we will not work on. They are field replaceable units. So if they break, we just swap them out. So power supply goes out on a computer, you yank it out, put a new one in. You can possibly send it off under warranty and have the manufacturer refurbish it, send it back to you. That's always an option. Just don't attempt it on your own because the results could be fatal in those instances. And it's not like you're going to be like, oops, I accidentally opened the box to the power supply. It is very well sealed. So it's going to take a lot of effort to get inside there. And they do that for a reason. So if ever you are asked, is there ever an instance where you open up and work on a power supply? It is a resounding no. There is no other possible answer for this. We don't do it as IT techs. All right. Fire extinguishers. Might be thinking to yourself, this is kind of silly. Do we actually need to know this? Yes. Yes, we do. Three main ones you need to pay attention to is class A, B, and C, though there are others. And there are combination fire extinguishers, but A, B, and C are the most important to remember, especially for the A+ exam. A is the simplest. It is for wood and paper. It is typically a canister with a pump on it, and it's usually pumping out water. So it's usually for wood, paper, and other combustibles like that. If you have a fire in your kitchen, though, that's not something you would likely want to use, because if anybody's ever poured water on a grease fire, you know that that does not end well. So you would need to go up to at least a class B, which is put out fires caused by liquids such as gas, kerosene, and oil. So class B, step up from class A for liquid fires, kerosene, gasoline, oil, things like that. And then the one, if you work in an office setting, which is the most important one for our purposes, is the class C, which is a non-conductive chemical used to put out electrical fires. For a while there, it may come up on the exam, they may mention it. For a while there, they use something called halon extinguishers within server rooms. Really good at putting out fires, really bad for people. It displaces all the oxygen in the room. So if you're in the room and a halon extinguisher goes off, you will have no air to breathe. So it does not work good for you. It's great at putting out electrical fires really quickly. But because of that, they are phasing these out, moving to a different type of extinguisher for things like places like server rooms and stuff like that, so that it's not such a risk to the people who are working in there. So A, B, and C. All right, now we need to be aware of ESD. You will hear this term used a lot, short for electrostatic discharge. Yes, Kayla.
So with the fires, to make it more simple so I can understand, A is kind of like for camping, for wood and stuff. You can think of it that way. B is kind of like for home, and C is like office settings.
You could view it that way. So like A would be like camping, B for the kitchen. Typically that's where you would see it, in kitchen. And then C would be the workplace. So yeah, that actually would make sense if you want to remember it that way.
Okay, thanks.
Mm-hmm. All right, so electrostatic discharge. Anybody ever run around when you were a kid with socks on in the wintertime and then run up and shock your siblings or adults or friends or whatever? Well, ESD is that is electrostatic discharge. It's got a nice little spark that comes across. That is extremely perilous to computer components. Now, as people, I think we can't even feel a shock like that until it hits about 20,000 volts. So we can't even register that it happened. 20,000 volts is what it takes for us to be able to register a shock. And I think you don't even see it until you hit, 2,000 volts. We don't register anything below 2,000. I don't think you see anything below 10,000. So if you see a spark, that's 10,000 volts. Below that, you won't even see it. So we don't feel it under 2. We don't see it under 10. Computer components like CPUs, RAM modules, almost any component in a computer can be damaged with as little as 100 volts. So you wouldn't even feel it. And you can catastrophically damage a component in a computer. So there's 2 different types of damage you can cause when you shock it. There's catastrophic, which means it doesn't work anymore, never will again, or upset failure, and it works intermittently, but not really well. So in order to mitigate this possibility, we actually need to neutralize the charge between us and whatever we're working on. So there's a few different ways we can do that. We can use an ESD bracelet, which is shown right here. It's a little strap, goes around your wrist, has a little metal piece that kind of pushes up against your skin, and it is attached to a wire that you will then clip onto a metal component on the computer to neutralize the charge between you and the computer you are working on. That way you will not damage it. They also have mats that you can stand on that are also grounded, that you can also work on. When you're transporting components from one place to another or storing components, you would store them in anti-static bags. So if you've ever bought a computer component, you open up, it's that kind of funny looking Ziploc bag. It has like that grayish, purplish color. That is an anti-static bag. It does not allow the charge to transfer between it. And then for those who say if you do a lot of work on hardware or you don't want to remove jewelry or anything like that, the general rule is pretty much you remove any jewelry before you work on anything electrical. Also anything mechanical. If anybody's ever seen a video of when that went wrong, you will never forget to do that. But the ESD gloves work in that sense where you can just wear the gloves over your hands and it doesn't allow the charge to pass between you. So techs who do a ton of work on computers may prefer to use the gloves because they're just more comfortable. You know, but it's just, it comes down to personal preference. One of these three will need to be used: the bracelet, the mat, or the gloves. And then for components, you would use bags for transport. So any questions with regards to that? And none of these items are overly expensive. Like you can get an ESD bracelet for maybe 50 cents, maybe $1. You can get ESD gloves for like maybe 10, 15 bucks. ESD mats, I think, are one of the more expensive things on this list. Those probably will run you about $20 to $50, depending on the type you get. Anesthetic bags, they come with any component you order. It's always good to kind of, like a lot of techs, especially if you work in the field a lot, will save those bags. If you have to throw a component away, they'll save those bags and just keep a couple of them folded up and tucked in their work tool bag, just to kind of have them on hand. So yes, Jessica.
So as a IT worker, do you, I assume, I guess, like making purchases where this is something where with time and more practice, you'll know to tell yourself like, hey, yeah, I want to hold, like you just mentioned, I want to hold on to this bag, this packaging in particular. Are these things that we ourselves will be ordering? Because I know you mentioned a few costs.
Mm-hmm.
You know, does ordering equipment, is that going to be, you know, something that, depending on the company we work for, may be a responsibility of ours?
Predominantly, the companies you work for will provide them for you.
Yes.
Okay.
But like with many places, the ones that they provide you may not be the ones you want to work with. They may not be the ones that you prefer to use. Like if you order new components, they'll give you screwdrivers inside the component bags, you know, and they'll be, you know, maybe little ones like this, if you can see it. So they're like this. They're not overly fancy or expensive or ergonomic. If you're going to be opening up computers day in and day out, and say like a thin handled screwdriver, you know, may not work good for you. It may hurt your joints to work on a thin handled screwdriver. So you may invest in something a little bit better for your personal preference.
Gotcha.
That's not necessarily something you would have to do right off the offset. You know, if you're doing independent work, contract work or something like that, yes, you may need to supply your own tools. Guys, a lot of times are like, don't really need a big reason to go buy tools. It's kind of an excuse. Like we look for the excuse to go buy tools. At least that's me. You're like, oh yeah, I gotta get it for my work. You know, it's like the new cable tester just came out. You know, mine's getting a little long in the tooth. It doesn't work as good as it used to. You know, so we try to find an excuse to go get those tools. But mostly in an enterprise setting, they are going to provide them for you, at least a basic set. Above and beyond that, if you want one that you like the looks of it better, or it works a little better for you, you may have to invest in it. So I guess it was kind of the same way. Anybody ever work in a mechanic shop? You know, they do have some tools at the mechanics that they'll provide those tools to the mechanics, but they're very, very basic and they're not that great. So a lot of mechanics will buy their own tools and bring their own toolboxes that lock and stuff like that. They won't let anybody touch their tools. So,
hey Kelly, I have a question for the gallery after you get Susan and Cynthia.
okay, and then I'll get to Glenn right after that. So yes, Susan.
So for Macs, I have zapped the pram before. Is that kind of like a electrical shock for, and is it not good for the computer?
Typically, no, not good.
Okay. It started working a lot better though.
Yeah, then I would say you probably got lucky.
Lucky, yes.
Okay,
That's funny.
that's all.
Cynthia, and then I will get with Glean right after that. You are muted, ma'am. I can't hear you. Great.
There we go. Oh, you muted yourself again.
There you go. There you go.
Because I have two different, see if the one on the desktop was working, that's fine, doesn't really matter. Now, I have a question because on one hand, you were saying protect yourself from shock, like we're not supposed to ground. Like that's
Yes.
for us, like we're not supposed to ground when we're powering down any type of like device, right? But then on the other hand, when we're dealing with equipment to prevent electrical static discharge, the mats are grounding. It's like they call grounding mats. So how does that work? Like, because we're not supposed to ground, but then we have these mats that are grounding.
Well, it's mostly you neutralizing your charge between you and the actual machine when we have the ESDs and stuff like that. And more when they're speaking about grounding out would be like, you know, if it's still powered on and then you ground yourself out on it, that's where it gets bad. So we want to negate the charge in it before we before we ground ourselves essentially to it. You don't want to ground yourself to something that's powered on or is attached to a power supply, is what they mean.
Right.
So you want to that's why I say power it down, disconnect it, then you attach your ESD bracelet. You don't do that before everything is shut down and disconnected. So a good question. It is a little bit nuanced though. Yes, Glean.
I think that most companies will give you the equipment that you need in order to work onto it. When I was working at Ditch, they set us up with all our tools, although a lot of it's stuck.
Yeah. And that's why I said, like, they'll give you a basic set.
But yeah, they're gonna set you up with the tools that are necessary for the job. Because if you had to go out of your pocket in order to make the expense on what you needed, and the company wasn't able to provide it or didn't, you could hold that against the company. So they're gonna give you the tools that are necessary, or at least what they deem is necessary. But let me know.
So they'll set you up with the basic set.
Every technician that I was there had their own stuff. I had my own set, because it's like, this isn't gonna cut the job. So
because I mean, you may find a tester that works better for you. You may find a set of screwdrivers or cutters or all that stuff that just, they work better for you. They fit better in your tool bag. Maybe the one they give you is a little bit too bulky or clunky. And you want something a little bit more streamlined. It's just, it comes a lot down to personal preference. Hemostats are great for electrical work and hobby work. I actually have a huge bag of them next to me. But yeah, so you'll get provided with your basic stuff, and then above and beyond that, you may purchase your own, and it goes with you.
Okay.
So
I just have a general question. This is I don't know that we've covered this yet, but I just want to see who might know this. Your tools that you are using inside a computer, is it a good idea to have say you drop a screw in the computer, you have a magnetized screwdriver? Is that a good idea to use that to retrieve that screw? Okay, I've got no's in chat.
Yep.
Okay. Let's see. Kayla, can you tell me why not?
I'm not really sure why not. I just know my husband was talking to me about it. He's like, yeah, that's a big no-no.
All right. That's a good answer. That's a good source.
Okay.
Let's see. Julian, why not?
To be honest with you, it just sounds like a no-no to me.
Okay.
I don't know. It might disrupt with any of the electricity or something like that. I'm not sure the exact reason.
Okay. All right. Lorraine, and then we'll see if we can get an answer here. Go ahead.
It can demagnify. It's a magnet, and it'll demagnify and erase memory.
Almost. Candido, what do you have?
I was gonna say something like what Lorraine just said. I believe if you put a magnet next to the hard drive, it could erase like some of the data. I'm not sure if I'm correct, but something. in
Well,
that
a
nature.
screwdriver probably wouldn't be magnetized enough to erase your hard drive, but it's not a good idea to do because you can damage your components. Magnets are not good to use in a computer, especially with your screwdrivers. You can damage components and not even know it. So I just wanted to throw that out there, something for everybody to keep in mind and think about.
Cool.
We all saw Breaking Bad. Be wrong. You said if I have not seen that.
Yeah, it'll be covered a little bit more later, but that's just a heads up.
Yep. So 4 methods of protecting against ESD. Good one to remember. High likelihood you'll see it again.
Yeah.
All right, protection rules. When you're working with someone else and you need to hand over a component to that person, you reach out with the hand that is not holding the component, touch them on the arm. That neutralizes the charge between you and them, and then you hand the component over to them. If you try to hand the component first, and that is the first thing they touch, that can create that spark between them and the component and damage it. So you always reach out, just pat them on the elbow or whatever, and then you can pass over the component after that. All right, like we were talking about, previous slide, keep components stored in anti-static bags when they are not installed in units, if they are ones that you are going to reuse or repurpose, so that you do not damage them. You never ever stack components, especially if they're not in anti-static bags. That can real high likelihood of damage at that point. Always try to work on hard floors, as we talked about. Running around on carpet with your socks generates that static charge. So you want to try to avoid working on carpet whenever possible, and or use an anti-static mat if that is what you're doing. When working on computers, humidity, that is a big one, especially for those of us who live in Florida, where we have 197% humidity every day of the year. Humidity, computers are very, very sensitive to it. They don't like humidity that is too low because of the static charge. It makes it much easier for static electricity to build up if you have very, very low humidity. Why might they not like high humidity?
Reference like a condensation, a sweat, it might cause, the equipment to, because I know it gets really hot sometimes, the heat and things, and that's just my small computer, let her know when you have a whole station area of computer items. There you go, moisture. Thanks, DW.
So Jessica, you were right. It creates condensation based on the humidity, and the moisture can do 2 things. It can create a grounding between 2 connections, causing a short, or it can actually cause the components to start to oxidize or rust.
That's right.
Which means that they will not have as good of a connection and they will not function properly. So DW, you will never see me ever mention anything about somebody else's spelling because I am absolutely terrible at it. I even baffle spell check, so. All right. So before you work on a component, you remove packing tape and other stuff from the room, as these materials attract ESD. One of the biggest ones are these little styrofoam peanuts. Oh my goodness, have you ever been trying to pull everything out and all the peanuts are sticking to everything? They're sticking to you, they're sticking to the boxes. If your kids run by, they're like attached to the kids as they go running into other rooms, and they do that because of static electricity. So that, that is a big, thing as to why, those things are hard to ever get rid of. So whenever you are going to be working on a component, you remove all packing material, take it and put it in another room, get it away from you. You don't even want it, you know, in the same hemisphere as you when you're going to be working inside of a computer. Next and finally, Mark and I don't struggle with this. You need to tie back long hair so that it doesn't fall into the computer. And also remove any loose jewelry. You don't want, like some people have like the dangly rings and stuff like that. You want to remove all of that stuff. You don't want that to possibly brush up against the component, cause a short, damage the component in that manner. So, all right. Yeah, we will talk about it a little bit later. As you're watching through, you see Mark, you see me, Professor Messer. Okay, I'll be in 1 second. Professor Messer, Mike Myers, even my teacher, John. We all have. I got it, buddy. I'll be in 1 second. All right, give me 30 seconds. I apologize.
Yeah, guys, it's one of those things. We're still trying to convince Avery to join the club, so we'll see how that goes. All right. All right. Does anybody have any questions right now?
All right. So you see all of us, we all have close cut hair and we have beards or some form of facial hair goatee. And you might be asking, is that a dress code? Yes. So you guys out there like Steven, you have, a little bit too much on top, might have to part ways with it here in a little bit. Avery's still in training, so we give him a little bit of a pass, but
For real, my hair not even that long.
it's part of the dress code, man. We can't get away with it. Ladies, you might have to get like an ironic tattoo or something along those lines. Can't help it, industry standard. Unfortunately, we just work within it.
Noted, thank you.
All right. So, tools and equipment that you will likely be utilizing on your day-to-day activities. This nice little tool bag here. Generation used to give these out. They may still do that. I never got mine. But it has a lot of the components you may utilize when opening up a computer. You have a, let me go and get my annotator out here. Right here, you have a sorter so that you have different kinds of screws, different threadings and depths, or whatever. You can sort the screws, various, types of heads for screws and torques. You also have, the ever-present wire cutters over here, your ESD bracelet right here, the non-magnetized screwdriver right here, and the one that we seem to miss here, I don't see it, it's not visible, would be a screw extractor. It looks like a little stick and it has like 3 little wires that come out when you press a little button on the back that will kind of grab screws. Instead of using a magnet to go in and pull screws out, they have a little grabber that you can go in and grab the screws with and pull them out, so you don't have to sit there and poke around with your fingers and try to fish out the screws that way. And then this is the one right here. This is called a chip extractor. Looks kind of like a horseshoe and has 2 little hooks on the end where you kind of grab the chip and you pick it up and move it. Whenever you're moving it from the packing material to the motherboard or back, always use the chip extractor. I have a good story for that. I will tell you in just a moment. Yes, Jessica.
I have a request, please, if it's not too much to ask. Mark did a great job earlier where he was like, this is important. So if something's gonna be on our exam, right? Would it be too much to ask to, just make it obvious and be like, hey, you guys might want to take note of this slide,
I mean, we'll do our best, but
yeah,
We'll do our best, but it's like, we don't want to be saying that every single slide.
All right,
We can
all
do
right.
that.
And that's kind of what I wanted to get a base reading
Yeah.
of. All right, say
So
no more. Gotcha.
What we'll
Thank
do
you.
is, like, you'll usually hear us key in when we know there's like 2 to 5 questions that you'll experience with it. You know, like if there's several questions that you will possibly see, we'll definitely key you in on it.
Yes.
So let me see if they have a better picture of the chip extractor real quick. No. All right.
I have a physical one. Give me a second.
I have mine in my tool bag. My tool bag's out in my car. So. So while she's getting that, chip extractor, very, very inexpensive tool. You use it to move the CPU from packaging to the, well, that's the screw grabber. Yeah, that's a really great tool to get fish out screws. I'm talking about the chip extractor itself, but thank you for that, Cynthia. That was great. Chip extractor kind of looks like this. And then it has these little hooks that come in, and it's almost like tongs with little hooks that will go right into the notch of the CPU itself. It may seem just easier to reach in, grab it with your fingers, and just go ahead and put it in place. So it may seem like that is the easier option. One, you run the risk of ESD if you're not properly grounded. The other one, in my cohort, we actually built a gaming computer, and they brought all the components in, and we all worked as a group to actually build the whole thing out. And we had a TA, poor guy, name of the Matt, and he came in and he had to handle the expensive part, which was putting the CPU onto the motherboard. And we were working with an AMD chip, which you'll know later means that is a PGI, which is pin grid array, which means there's a ton of little tiny pins that stick out of the bottom of the chip. They're about the width of a human hair. There are hundreds on there. And when he picked it up out of the box and he was going over to put it into the CPU, he was a little nervous because he was in front of the entire class and ended up dropping the CPU, and it banged on the side of the computer, bending about 30 of those pins. Just because he was a little nervous handling the CPU. Now, all of that could have easily been avoided had he utilized the chip extractor. Thankfully, I had a precision kit in my car with a magnifying glass and all that stuff. And then we spent the next hour and a half straightening all the little pins on the back of the chip in order to get the CPU to actually fit into the motherboard. And thankfully it turned on and worked. So always remember that story. Use the chip extractor, and you know, you won't run into that particular situation. All right. Your drawings. We'll be going over tools again as well. So this is just, again, mostly just kind of an overview. They also have good pictures of them in your Cybex book when you get into that. All right, next we have a post card. POST stands for Power On Self-Test. The computer goes through a series of checks real quick. Every time you turn that computer on, make sure everything is okay. If it's not okay with the basic checks, you'll hear a series of beeps. A series of beeps will tell you what is particularly wrong with the computer. They do have a thing right here called a post card, although I don't know many IT professionals who actually utilize one of these, but they are out there if you want to use them. And you can plug them in and it will give you a code number that you can look up and see what the issue is. Although typically what it is, if you hear the number of beeps, just you count the beeps, you look up the motherboard manufacturer on Google and it will tell you, you're like, hey, I got 4 beeps. What does that mean? And it will tell you what the beeps mean. Although the easiest way to determine it is if you just messed around, like you just took a component out and put another component in, that's likely what the problem is. Like it may not have been seated properly, not plugged all the way in, and it doesn't detect it, and that's what's causing the problem. So if you just replaced or you added a RAM module. It's like you took out the old RAM module and then you put in a new one, and all of a sudden you get a beep, it's likely that the RAM module wasn't seated in there properly. So think about what you just did, and a lot of times that will tell you what the problem is if you're getting a post error. Questions so far? So power on self-test, post. All right. Next, networking tools. There are a variety of tools that you can utilize while networking. Many people might be familiar with these. A multimeter, good for testing the voltages, ohms, and or continuity of electrical components. You got, go back 1 second. Okay, yeah. There you go. All right, just give me a thumbs up when you're ready to go. All right, good. So next we have our networking tools. So the multimeter, like I said, right here. This one right here is called a punch down tool. Now, when you're doing actual networking, like running the cables to the server rooms, you'll have something called a punch down block. And that is how you will essentially connect your horizontal runs to the actual patch panel so that you can connect things to servers and all that stuff. And then the other side of those cables are going to be the receptacles in the walls where you plug in your networks. And on the inside of those receptacles, you will have another little punch down block, which we have a video which will show you how to do it, where you have to push each one of those little tiny wires in, and they will lock into place, and it cuts off the ends of them so that you can actually plug a network cable in there and it works properly. So this is called a punch down tool. One side of it is flat and will push the cable in. The other side has a blade on it that will cut the cable, the little piece of the wire off so that it's cut flush. Up here, this is a crimper. So this is if you are making the network cables themselves. And in here, it has two holes you can see right here, which is like the network, the Ethernet cables that have those little wide ones. And then for those of us who've been around forever, the old telephone connectors, or what we call POTS, which is plain old telephone service, POTS, right here. Or it's also called an RJ11, but we will get into that when we get into cables and connectors, I believe, next week. So RJ45 is your network connector. It's that little wide connection piece that has like 8 wires in it. And then you have the RJ11 or POTS, which is the old school telephone connectors that have 4 wires. And this helps you crimp those plastic pieces onto the end of those wires. All right, cable stripper. This one is actually in the crimper. It has a cable stripper right here to strip the sheathing off of a network cable so that you could get to the wires inside. And you might be thinking to yourself, do I really need to know what order those wires go in? Is there something special about that? Yes, yes, you do. Yes, we will. We will talk about it. We'll get into it, and you will know the 2 main standards that we work with in the industry, and you'll know what a straight through and a crossover cable is, when you would use them, why you would use them, and how to wire them. Next, you have a tone generator and probe, which typically is a box that you would plug an Ethernet cable into. I'll have a better picture of it here in a little bit. And then that sends an actual musical tone through the wires. And then on the other side, there's a probe that you would put in if you're trying to figure out which outlet goes to which receptacle on a patch panel. When you touch it to it, it will give you a nice little beep. But we will, again, I will show you a better picture of one of those. It's called a tone generator and probe. The nickname that you will hear them called quite regularly is Fox and Hound. So you have a tone generator and probe, also known as Fox and Hound. So one chases the other. All right. This right here is a cable tester. So if you're making cables, you want to make sure that you did it right, because trust me, you don't want to install all this stuff and then find out you didn't make the cable properly. So you would plug one end of the network, my annotator out here. You would plug one end of the network cable in here, the other end of the network cable in here. These two pieces actually can disconnect from each other. And then what it'll do is it will light up a series of lights, and they say 1 through 8. And each one of those correlates with one of the wires inside that cable. And so it will tell you if all of the connections are correct. So it'll test every single wire in that cable, make sure the connections are correct. If they're not, means you might have a bad connector, so you can replace the connector and see if that's good, or it's a bad cable. I cannot tell you how often when people have internet issues, it's just a bad cable. Because many times in offices, we have the towers sitting on the floor, which you really shouldn't do that, but they have the network cables basically running out behind it. People are kicking it all day. Whenever the cleaning crew's in, they're hitting it with a vacuum cleaner. Sometimes they even have these things on the floor and people roll over them with their chairs. You know, sometimes they'll get, snatched a little bit, and, it breaks these tiny little fine copper wires in there. And so the cable becomes bad. So you just replace the cable, it fixes the issue a lot. So don't discount the hardware involved, like the cables, when you're troubleshooting network issues, because that could possibly be the problem. Your horizontal runs in the walls, highly unlikely those are going to be the problem, because those tend to be a solid core wire. Very robust wires run through walls. So those tend not to be the problem. It typically will be your little patch panel cables on either end. That typically is where the cable breakage will happen. All right, loop back plug. It looks like a little network cable that's just been cut off, and it's a nub. And what it does is it sends the signal back into the machine. The sole purpose of a loop back plug is to tell you whether or not your physical hardware NIC is working. That's all it does. It takes the outbound signal, pushes it right into the inbound signal of that computer, and it causes the light on the NIC to light up and just tells you, yes, it's working. That's the sole purpose of a loopback plug. They have a software command that you can use to do the same thing, but this is a hardware way to do it. It's just a quick test. I have one of these. I will, when I bring my tool bag in, I will show you guys probably tomorrow. Yes, these are tools that would typically be provided by the company. All tools you need to do your job should be provided.
Yes.
Unless you're an independent contractor that's just kind of doing piecemeal work for multiple companies, then you would need to provide it yourself, because then you are the employer typically. And the companies you work for are just your customers. And lastly, you have a Wi-Fi analyzer, which will basically tell you the signals that are being operated on in any given area, what channels they're operating on, and whether or not they are present. But we'll talk about this a little bit later, because they are not only common tools used by IT techs, they're also common tools used by hackers. Although you can get Wi-Fi analyzers, like software versions of them, install them on your phone.
Yeah.
Pretty inexpensively. Some of them might be free. Questions so far? All righty. At this point, we should now be able to describe on a basic level how computers work, including the relationship between hardware and software and firmware. We should be able to explain the key safety procedures to take and tools to use to protect yourself and the computer. Questions?
May you please go back to screen 1 of 3 and 2 of 3